Okay, folks, so here's the problem we got today. We got to code a simulation of a ball with both negative velocity and negative acceleration. How do we do that? Let's check it out. IIT JEE. Alright folks, let's go ahead and code a ball with negative velocity, negative acceleration. How do we do that? Let's start with a sphere. If I do that, that's all I need to make my ball, literally. That's my sphere. That's my ball. Now I gotta give this name a variable, so I'm gonna call it a ball, and I'm gonna give that ball a velocity. So ball.v is equal to vector -1, 0, 0. What does that mean? That means my ball is gonna go in this direction, negative x direction. I also gotta give the velocity a magnitude, so I'll give it a magnitude of 1, 0.1 actually, so it starts basically from rest. I also need to give the ball a negative acceleration. Remember from the problem, we got to give it a negative acceleration, and let's make the acceleration 1. Yeah, so the ball starts speeding up, maybe. If you watch the previous video, you'll know the ball is speeding up, but this time we'll actually get to see it. Now if you refresh the page, you'll see that nothing happens. The ball's still. It's not moving. Why? Well, we got to put in some frame rates. So let's say the time is 0, the time step is 0.05, and while our time is less than 5 seconds maybe, we're going to increment the ball's velocity, and we're going to say the ball's velocity is its acceleration times the time. Same thing with the position, basically. Our position is going to be the ball's velocity times time. Also, make sure you establish the frame rate as about 100. Don't forget that you need to increment your time element t plus equals dt. And now we can actually watch this thing in motion. You see that? You see that? Now to actually add, something that will help us visually deduce that it's accelerating, let's give it a trail, make trail equals true. And if you see that, you're gonna see it start to poop out some, nothing. Oh, I put it in the wrong place. What do you know? Good old refast. So we're gonna actually put this right here. And so now the ball is gonna make a trail as it moves along. That's gonna help us deduce that it's actually accelerating. Alright, so that trail is just this freaking rod right here. I'm gonna make that better. I don't know about you, but that doesn't help me aid or deduce that it's accelerating. So I'm gonna say that the trail type is points. Okay, so maybe that'll help us figure out if it's accelerating or not. And okay, these points are really close to each other. Let's make their interval 5 or something. Okay, let's see now. Okay, now check that out. There's something really cool to be learned from here. In the beginning, the points are really bunched up close to each other. It's like the New York City subway. And then near the end, if you look at the trail, you'll see that these points are much farther apart. And that's because the ball is accelerating. In fact, if I make the acceleration super huge, the distance between these dots is gonna get super huge. Check it out. Let's see if that works out nicely. So it's loading program, and check that out. In the beginning, we got some bunched up guys. In the end, we got like super far away people. I mean, this is crazy. They're like island nations. Alright, I'm gonna revert the velocity back to 1. Now I'm gonna add some vectors so you can see this thing in action. So how do we add vectors? We're gonna add an arrow, and we're gonna say the position of this arrow is in the same position as the ball. Okay, so that's gonna be my velocity vector. And let's also add an acceleration vector. I think they're pretty cool. Vectors are cool. And I'm gonna say my velocity vector is orange. Let's say the acceleration vector is red, because acceleration is cooler than velocity. And don't forget to define the magnitude of these vectors. Jesus Christ, I mean, can you believe it? I almost ran the program without defining the velocity, the magnitude of these people. Okay, so what's the magnitude of the velocity vector? Same as the ball's velocity. And for acceleration vector, its magnitude will be same as the ball's acceleration. Since the velocity is 0.1, yeah, let's just keep it. Alright, good. I might want to make the acceleration vector, I'll just scale it up a bit, maybe 1 is too small. Okay, so now if you go ahead and run the program, do you see the vectors? And the vectors are left in the dust. That's embarrassing. Well, here's what you gotta do. You gotta move these vectors as the ball is moving. So how do you do that, you might ask? Well, you say the velocity of the vector its position is going to be the same as the ball's position. Same thing for the acceleration vector, by the way. We're going to say ACCE vector's position is equal to the ball's position. Now if I refresh the page, it should follow along. So the acceleration vector, as you can see, is following along the ball. But where's the velocity vector? Where's the orange thing? Actually, I have no idea. I'm kind of nervous that this thing might not work after all. Okay, yeah, this is messed up. Let me see. Maybe I gotta scale this thing up 10 times. Oh yeah. I'm not incrementing the magnitude of the velocity vector. So its axis has to equal the ball's acceleration vector axis. Okay, cool. Let's see if that works. Cross your fingers. And yes, you can see the orange vector has overtaken the red one. I don't know if it's going to be easier for you to see that if I make them translucent. I'll make the orange one 0.5 opacity. Same thing with the red one, as a matter of fact. And let's reload this thing. Let's see what happens. Alright, so moving. Oh, wow. Now, it's a little bit hard to see because these things are moving so fast. I can slow down their speed, but here's a better thing. I'm going to make the camera actually follow the ball. So I'm going to do that by scene2.camera.follow ball. It's as simple as that. How to get rich quick fast. I'm joking. Okay, so let's see. Oh wow, check that out. Velocity vector in orange, acceleration in red. You got the trail behind it. That is cool. Now, because I want to be super cool, too cool for school, we're gonna make some AT, VT, PT graphs. You know what those are? Position vector, acceleration vector, velocity vector graphs. So how do you make a graph here? Well, it's not too bad. You write T graph equals graph. Seriously, it's that simple. And you can write fast equals false to make it super cool. And scroll equals false. And now if you reload the page, you'll see nothing. Why? We haven't established something on the graph. Every graph has 3 components: a graph, a plot, and a curve. Let's do that. How do we add the curve? Well, we can say F1 equals G curve, and that's it. I'm serious. You can actually define its color, but I'll do that later. Let's cross your fingers that this thing even works. Alright, so now I'm gonna make sure that this graph auto updates in real time. So I'm gonna say f1.plot ball's position versus dt versus the time. And so let's see if this thing works. Cross your fingers. I'm seriously nervous. Oh, cannot plot a vector, only a vector component. Okay, sure. I can make it the x position. That's the only thing that's changing. Okay, cross your fingers. Okay, is it? Oh god, I can see it's graphing something, but I just can't see what because of the camera in the middle of my face. Wow. Oh, this is seriously messed up. Did I mess up my? Oh yeah. Okay, so I mixed up my x and y axes, so this should be first. Okay, now hopefully it should work. Okay, so let's see if this thing works. Okay, so no, it's just a straight line through time, and that's definitely not what's happening. So how do we fix this thing? Well, t is less than 10, dt ball dot position x. Okay, so instead of ball dot position x, what can we do? What is possibly going wrong here? Well, what's staying constant? So the velocity is changing, but the time is not. So let's say instead of dt, let me just write t. Maybe that'll work. Hopefully. If it doesn't, I have a backup plan. Oh wow, check that out. You can see this thing's actually, as we expect, it's a parabola, right? Because the integral of acceleration is linear, integral of linear is quadratic. That's why we get a quadratic. That's pretty cool. Now let's plot the other things. Can I give this thing a color? I don't know if this is going to work actually. I'm also going to try to give it a label, position. Absolutely zero idea if this is going to work, but hopefully it does. So I got the color going. I don't have any labels on this thing, but I guess that's okay. What else do I want? I want an x title on this thing. X title equals time, so that's gonna give us a title, and title of the whole graph, I'll just say it's trajectory. Okay, what else? Okay, let's make another graph for the velocity. That was the position, by the way. My second graph will be velocity. We'll do that in green. And I do not need this label. I want it to label, but it doesn't work for some reason. And I'll make a third graph for acceleration. Okay, when in doubt, write it out. So F1 plot, F2 plot, F3 plot, and ball dot velocity, ball dot acceleration. And yeah, I hope this thing works. Cross your fingers. All right, reload this thing. Let's see if it works. Wow. Okay. Wow. Check that out. That's amazing. It actually works. All right, ladies and gentlemen. That's how you code a ball with negative velocity, negative acceleration. That's how you make a position graph, a velocity graph, an acceleration graph, all in 3D, all in VPython. That's how you show a ball is speeding up with negative velocity, negative acceleration. We'll check you out in the next episode of IIT JEE Physics.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.